Welcome back to Programming Windows Forms application tutorial. We're still on lesson 3, which is creating a practical application, which we've already started. Um, Today, what we're going to do, just a recap, let's look at our program. So this is what we have as our program so far. This is what we've done. We've created a user interface. I'm just going to click on play so we see what we've done. So we've created the user interface. We've populated the journey start point entries and the journey endpoint entries. So what's left now is to code out what happens when the user enters a number in here and clicks on the calculate button. So he's supposed to see a distance. That's the distance between the starting point and the end point, and also the payable allowance for the trip. So that's going to depend on whatever the user enters in here. Okay, so we're going to start coding now. I'll just terminate the application now and go back to our code. So the first thing I would like us to do is let's go to design view, by the way. So let's handle this text box. Okay, I've forgotten the name we gave it. So let's just go to the properties window, look up the name. So we called it allowance per kilometer, allowance per km text box. And also notice the way we wrote the name of the variable. It starts with a small a, allowance, then a capital P, a capital K, and a capital T, and a capital V. So each word we capitalize the first letter. Okay, so really since we know that, so that's just what we need for that. That's for the text box. We just need to know the name of the text box, and that's it. um we're going to go ahead into coding out what happens when the user clicks on this calculate allowance button, keeping in mind the name of this text box. Okay, we also know the name of this and the name of that, but for now let's just worry about what happens when the user clicks on the calculate allowance button. Okay, so in the first or in the second, I think it was in the second lesson of the programming Windows Forms application series. In the second lesson, we saw where we created a program where the user clicks on a button and the background color changes, which we said is not very interesting, and that was why we're creating a practical application. So if you remember, when we actually set up the click of that button, we just came to the design view that's here, and we double clicked on the, okay, I think we didn't double click, we actually selected the button and then went to the properties window, selected the events tab, and then went to the click event, and then on the right we double clicked there, which created the event handler for that button click. Okay, that's one way you can create the event handler. Another shortcut, which is much shorter than doing all that, is you can just come on top of the button in the design view that's here and just double click on the button. Okay, so I'm in the design view here. I just come on top of the calculate allowance button and I double click, and notice opens it goes directly to the code for me and it creates this code. Okay, so this is look at where it created the code. Let me just minimize this public form 1 constructor, so you see where, so usually if you minimize, it just collapses the code. Is these three dots are just telling you that this public form 1 constructor has some code in it which we've minimized. Okay, so you can see where it created the code. It created the code within the form 1 class. Okay, the form 1 partial class. but it's not inside the constructor, the form1 constructor. Okay, so so far these were the variables we created. Remember when we were creating the names of the states, or yeah, the names of states or names of cities, and the remaining of our code went into this constructor. That's when the form is being constructed. That is when the combo boxes get populated. So now this is where the code for the event handler for the compute button. Also notice that because we named the button compute button, it is creating the event handler with this name. Now, this is not actually very necessary. You don't have to call it in this way, that you don't have to call it compute button underscore click, but it's just a convention which I believe Visual Studio uses. Okay, but remember, if you want to change this name, okay, there are places also apart from here. You know, this is where the code for the event handler was created by Visual Studio. There's still another code that was actually written by Visual Studio, okay, apart from this one. So if you're going to change the name of this compute button click event handler, you have to go into the other source file and also make sure you change it. So let me just show you where that is. If you come to the Solution Explorer on your right, top right, and you look for the form1.designer.cs, and you double click on that, down here you can see under the Windows Form Designer generated code, you will see all the code that was written by Visual Studio. Okay, and if you look in there, I believe you should be able to see where the okay, it's not in here. I can't find it. Oh, okay, here it is. So this is it. Private system.windows.forms.button compute button. Okay, so this is where the okay, this is for the compute button. Actually, this is the name where the name of the button was created, not the event handler. Let me see if I can find if there's anywhere the name of the event handler was used. No, I don't think it did. Okay, so it didn't really use the name of the event handler, but you should always watch out for things like that. Okay, so for the event handler, it didn't really use it in here, but I was thinking there's a place where it actually used it, but I can't find it. Okay, don't worry about that. Just make sure that if you're changing, okay, let me just show you just in case. So you can see the name of the event handler is compute button underscore click, right? If you go to the design view that's here, okay, and you select that, you click on the calculate allowance button, you select that, and you head to the properties window, and you click on the window on the events tab. That's this one, this little lightning sign. You will see that under the click property to the right, you can see compute button underscore click is written there. Okay, so if you change the name of this event handler here, you have to make sure you come back here and make sure that the name coincides with the name that's written there. Okay, also if you're changing the name of the button, okay, for changing the name of the button, I believe Visual Studio will actually do that for you. Okay, so you don't have to worry about changing the name of the button. Okay, so let's go back to our code view and finish up the code. So if you remember, this event handler actually creates like a section for you where you write code that gets executed when that button is clicked. That's the whole job of this event handler. Okay, whatever code or lines of codes you write inside this event handler, you can see it's like a method. Okay, whatever code you write in there, that code is going to be executed when that button gets clicked. Okay, so what code do we want to write here? The code we want to write here is for the program to take whatever number is written in here, that's whatever is set as the payment per kilometer, and use that to multiply by the distance between the starting point and the end point. Okay, so let's just do a little mock. It's not going to be exactly how the program is going to work, but we're just going to test out what's going to happen if the user clicks on the calculate allowance button. Okay, remember, for the actual program to work the way we want it to, we have to first know the distances, which we haven't fed the program yet. Okay, so that's why I said it's just going to be a mock or a test. It's just going to be a testing code. Okay, but that testing code is going to stand in place, like it's just going to be like a part of, or what what's going to be, it's going to be very similar to the code we are going to actually write at the end of the day when we finally populate the distances between the between all the cities. Okay, all right, so let's go to the code view. By the way, I'm going to close this form1.designer.cs. You go to form1.cs, which is the code view, and in here what we're going to do is first we're going to take allowance. Remember the name of that text box, it's called allowance per kilometer text box. That's this. We're going to take that and we're going to say dot text property. Okay, so the text property is what returns whatever is written inside this text box. Okay, that's why we're using dot text. The dot text property of this allowance per kilometer text box is going to return whatever is written in here. Okay, so if the user writes 50, 50 will be returned. But one thing you need to know is that, you see this dot text property, by the way, let me just highlight it and notice what it's saying. After the little spanner, okay, you can see it's saying string, meaning that what is going to be returned is going to be returned as a string data type. Okay, if you remember a string data type, it's not a number. Okay, a string data type is not a number. But what we're going to do is we're going to take the string and then we're going to try and convert it into a number. Okay, so for instance, if the user writes 12 in that text box, what is going to be returned is going to be the string 1 2. Okay, the string 1 2, that's 1 and 2 joined together. It's not a number actually, it's just a combination of characters 1 and 2. Okay, but when you try and convert it, that we're going to do what is called a conversion from one data type to another. Okay, we're going to see, we'll eventually see how to do that. When you do that conversion, it's going to take that 1 2 string and it's going to convert it into a number depending on the data type we tell it to convert it to. So if we tell it to convert it to an integer data type, for example, it's going to convert that 1 to 12. Okay, so the result is going to be 12. Okay, all right, let's just go ahead and write the code and we'll see what's going to look like. So allowance per kilometer text. Okay, first let's say string. Okay, not string, let's say, no, not int, let's use a floating point data type. Okay, so we're going to use float and we're going to say allowance per kilometer. Okay, so I've just created, notice what I did, I just created this is a variable, and the variable is going to hold a floating point data type. So a floating point data type is actually a number. Okay, and then now I'm going to say allowance per kilometer, that's this floating point data type, is equal to, then I'm going to take this text. Remember I said this is going to be a string. Okay, and then we're going to take it and try and convert it to a number. Okay, so we're going to say float. Notice how you do that, you're going to say float dot parse. This is the method that converts a string to a floating point number. Okay, so just to let you know, there are other methods. If for instance we want to convert this same string to an integer, you use int.parse. Notice the parse is with a capital P. Okay, so if you use int.parse, it usually opens a, it's a method, so you have to open a bracket and close the bracket, and in between the brackets you provide the argument, that's the string. So for example, if I put say for 45, you notice that this 45, because it's delimited with double quotes, it means this 45 is actually not a number at the moment. It's 45 string, that's 4 and 5 characters, that's the two different characters kind of joined together as a string. Okay, but by the time we call int.parse, what is going to be returned is going to be 45. Okay, that's 45 as an integer because we used int.parse. So I can do something like int x equals this. Okay, and by the time we tell it to print out x, or we say it should write out x to our output, you will see that x is actually 45 as a number. That's 45 integer. Okay, so it's very similar. I think double also has the same double dot parse. You can do the same for double dot parse. You can see double dot parse also has that. The only one I haven't used before, I think, is bool. So let's see, does bool dot parse have? Okay, it does. The bool data type also has a parse method which you can use to convert a string. So if you have a string looking like I'll guess it's something like this, looking like this, true, you can actually convert it to a real data type, to a boolean data type by so notice that the actual boolean data type is true, like this, true, without any double quotes. Okay, but because when you put double quotes around it, it's going to be taken as a string. Okay, so if you want to convert it to this true, that's this boolean data type, you just call bool.parse. Okay, so I'm just showing you the different data types you can convert to, that you can take a string and convert it to various different data types. So in our program, what we actually want is we want a floating to be converted to a floating point number. Okay, now there are some things you need to know. What if the user enters something like GHI? You notice this is actually a string that cannot be converted to a number, isn't it? Now, what happens if you call float.parse or something like this? Because it knows it cannot convert this to a float, it's going to return a 0. Okay, so if you should try to convert this to a number using float.parse, the result you will get is 0. Okay, just keep that in mind. There are other things. So okay, for example, if you are passing GHT23 HJ, what's going to be when you try to convert this to a number, I believe 23, it's going to convert it to 23. So it will just look for the text that contains numbers and try to convert those characters to numbers, and the ones it cannot convert, it just ignores them. Okay, so just play around with the parse method, and you'll get I'm sure you get your head around it. Okay, so for now, what we want to do is we just want to get the allowance per kilometer and want to convert it to a floating point number. Okay, all right, so by doing that, by saying allowance per kilometer equals that, it's going to convert that to a floating point number. Next, what we're going to do is we're going to populate. Remember, okay, first we're going to show the distance between the starting point and the ending point. Now, because I said we haven't actually fed the data for the distances, we're just going to use an example data, okay, a dummy data, okay. So let's assume the distances between all the cities is 100 kilometers, okay. So we're just going to assume they are all 100 kilometers, and then we're going to test with 100 kilometers. So we're going to say uh, distance. Okay, let's make distance an int distance, or let's make it a float actually. Float distance equals 100. Remember, we said we're going to assume all the distances are 100 kilometers, okay. And then next, what we want to do, notice that all this code is going to be executed when the user clicks on the button, okay. Okay, next, what we want to do is we want to get the let me just look that up, payable allowance, okay. Okay, so float payable allowance is equal to distance multiplied by the allowance per kilometer, okay. All right, so now we have all the details we want. We have the distance, and we also have the payable allowance. And remember, what we want the program to do is to show the distance here and also show the payable allowance in here, okay. So what we're going to do after that, that's after computing the distance and the payable allowance, we're going to say distance, what did we call it? Yeah, we called it distance output text box, okay. So that's this text box, that's the name we called it. If you're not sure, click on the text box, go to the properties window, find the text, the name property, and if you look for, oh, okay, we're on the events tab, we have to switch back to the properties tab, and then look for the name and name property. Here's the name property. You can see the name of the variable is distance output text box, okay. And for this one, for the payable allowance text box, I believe we called it allowance output text box, okay. Also, another thing you should know is the moment, if you can't remember what you called it, if you know the text box, if you're using my naming conventions, okay, if you notice the way I name my variables for anything that's a text box, if I'm going to create a variable that's going to reference a text box, I always end that variable with a text box. Now notice what happens if I can't remember the name of the, and I don't want to waste my time going to the properties window, I'll just type text box, and you can see in here I can see all the options for text box, and you can see I can look for the one I'm looking for. I know I'm looking for the allowance output text box, okay. So that's just another handy way. I want to show you that Visual Studio also gives you this option, okay. All right, so we're going to say allowance output text box is equal to, now remember, payable allowance is a floating point number. I believe you can still populate a text. Okay, so what I'm trying to say is that, by the way, allowance output text box dot text, don't forget, is the dot text property you want to set. So what I was trying to explain is, remember, this is a floating point number, okay, what we've just calculated, payable allowance, a floating point number. Allowance output text box dot text expects a string, okay, it expects a string. Now what I was thinking is that even though this is a floating point number, if you provide it will still work. But the reason why it will still work is that Visual Studio or C# will, by convention, convert that floating point number back to a text before it populates it. So let's just go ahead and try that out. Payable allowance, and put a semicolon. Does it complain? Okay, it does complain. So you can see you have to, because by the way, if you highlight it, you can see what it's saying: cannot implicitly convert type float to string, okay. Now, that what that is saying is that it cannot convert this this floating point to a string implicitly. Okay, you have to explicitly say convert this to a string for me. Okay, that's it's actually not a very good error message, I admit, but I think when you begin to write code and you begin to encounter these error messages, you will begin to get familiar with them. Okay, all right, so what we need to do is we have to convert this back to a string before we can populate the allowance output text box dot text property. Okay, so payable allowance, we're going to say dot. Now notice how you convert. If you remember, to convert from string to floating point number, we said float dot pass, and then in bracket we pass the string. Now, if we're converting to a string, you just call the name of the variable you want to convert, and then dot to string. Now, this dot to string method is present in every single object you're going to encounter. The reason is because actually every object in C# inherits from the base object. I don't know if I mentioned this earlier. That's when we were doing the basic C# tutorials. That's in the previous series that we covered. I can't remember if I mentioned this, but let me just bring up Notepad, okay? And I think it's quite important to know this, that every class you create in C# by default, even if you do not tell it, even if you do not specify that is a subclass of the object class, by default is a subclass of object class. Okay, so there is an object class in C#. Okay, I know I'm not sure we have looked at it. There is an object class. Okay, just keep that in mind. An object class in C#. It comes with C#, so it's not like it's a .NET thing or anything like that. No, in every C#, that's irrespective of whether you're working with Visual Studio or not, or you're working on .NET, as long as you're coding using C#, there is an object class, okay? And every class you create. So, for example, let me bring up this form1 partial class, okay? This form1 class, you can see it inherits from form. If you should look at the form class, it does not explicitly inherit from object, okay? It's not like in the definition for a form class, you define anything like is a subclass of object. But even without that, the form class actually inherits from object. And because form1 inherits from form, so form1 indirectly also inherits from object. Okay, every single class you create in C# is going to inherit from the object class. Now, why do I keep narrating this? The reason is because whenever you write the name of an object, or if you write the name of variable which references an object, and you put the dot symbol, you will see that there's always a toString method. That's one. There is always an equals method. That's two. I think there's a get hash code, and I think the other one is the get type method. Now, those methods, those 3 or 4 methods, are methods of the object class. Okay. Now, remember, if you inherit, or if a class is a subclass of a particular class, if B is a subclass of A, then B is going to have
every single object that A has. Okay, so that's the reason why almost every object you call and then put a dot in front of it, you will see that you always have access to this toString method, the equals method, the get hash code method, and I think the get type method. Okay, those methods are always available because they are methods of the object class, and because every class in C Sharp, whether you specify it or not, is going to inherit from the object class. Okay, all right. Let's head back to our code. So all this explanation is so that you do not start wondering where this toString method is coming from. Okay, it's coming from the base object class. Okay, and you usually use this toString method to convert something that's not a string. So irrespective of the type of object, it always has a toString method which converts it to a string. Okay, now the particular string that it converts it to, I don't think we should really go into details of how the conversion is made. Probably in a later class, I think we'll talk about that. But for now, just know that if it's a floating point number, if you call a toString method, it's going to convert that floating point number to a string method. So for example, if what we have in here in the payable allowance is 23.4, what is going to be converted to is going to be converted to 23.4. Okay, as a string. That's a character, a combination of 2, 3, dot, and a 4. All 4 characters are just character strings. Okay, and then because we set this to that, it's going to display it on the allowance output text box. Okay, then finally we will also want the distance output, that's the distance output text box, to display. So we're going to say distance output text box text is equal to distance, that's the distance dot to string. Remember, the distance is a floating point number, so if we're going to put it in a text box, we have to convert it to a string. And also remember that toString is a method, so it must have a open and a closing normal bracket, and use your semicolon. Okay, so I'm just going to go to file and click save all. So this is all these lines of code are what are going to be executed the moment the user clicks on that button. Okay, on that compute button. Okay, now if by the time the user clicks on the compute button, he has not populated this payment per kilometer text box, then obviously it's just going to convert that empty string to 0. Okay, remember, if the string cannot be converted to a number, it's always going to convert it to a 0. Okay, so let's go ahead and just test run this program and see what happens. Okay, so we're going to click play. Remember, I said we're just testing, and we haven't provided the details, that's the data for these distances. So in our code, we just set every distance to be 100 kilometers. Okay, and then in here we're going to say payment per kilometer, we're going to see $100. Okay, so I'm going to click in there and I'm going to type 100. Okay, so remember, this at the moment is a string. It's just a 1, a 0, and a 0. So it's just a combination of 1, 0, and 0. But in our code, it's going to take that string and convert it to a number, a floating point number, which is going to be 100.0 or 100.0f. That's the floating point number, and then it's going to compute this the distance of the journey is going to be 100 kilometers. That's not this 100, the hard coded 100. Okay, so by the way, let me just change this to 1000. Okay, so this 1000 is the payment per kilometer. So if the user is going to travel 100 kilometers, it's going to be 100 times 1000. That's $100,000. That's 100,000 naira. Okay, Um, for the distance of the journey, remember we said we've already hard coded it to be 100. So it's always going to show 100 irrespective of the distance, the cities that are selected. Okay, that's for now. For now, that's because we're just testing. And then the payable allowance we're going to see is going to be a computation of whatever you enter in here multiplied by the distance between these two cities, which is 100. Okay, so let's click on the calculate allowance and see. You can see that works. So the distance of the journey between Bauchi to Damaturu is 100 kilometers, and then the amount, the payable allowance, is 100,000 naira. Okay, okay. You can see if you change this to 20 and click on calculate allowance again, it's going to calculate the correct allowance. Okay, but like I said, what irrespective of the distance we set, you can see that it always uses irrespective of the cities, it always uses 100 because we had coded 100 in here. Okay, we had coded the distance as 100. Okay, all right. Now the next step we're going to do, which I believe it should be in the next class. Okay, but before we go to the next class, we're going to set it our code up to be ready for the next class. Okay, so if you look in your distance, rather than say we should just use 100 kilometers. You can see this is the hard coded 100 kilometers. What we're supposed to do is we're supposed to check by checking these two combo boxes, look for what the user selected as the starting point journey and the ending point journey, and then use those starting point and ending point to look into our database. That's the database for the distances, which we haven't provided now. Okay, so that's the two things we need to do. First, we need to provide a database for the distances. You can, if you remember, in the web-based version, we actually had coded it into the code. In this one, for the Visual Studio, for the Windows Forms application, we're not going to do that, okay, because there are so many drawbacks to actually hard coding something like that in your code. For example, if the distance changes, so for example, the distance from Kaduna to Abuja is say 100 kilometers, okay, for example, and then all of a sudden, after 2 years, the road, let's say a bridge was constructed across some river which was actually separating Kaduna and Abuja, which made the road to like go around the river and made the road a lot longer than it should be. But after the construction of the bridge, the distance becomes 50 kilometers. So there's a change in the distance. Okay. Now, if that occurs, you will notice that you will have to provide a patch for your program. Okay, you will have to provide a patch for your program. If that occurs, you'll have to go back. So if it's a program that you've already built and sold to people, they cannot just use that program. The moment the distance changes, you will have to go back because you had coded those distances in your code. You'll have to go back, rewrite the code, and then rebuild the program again, and then distribute that program again to your users. Okay, your users have to install that program. Usually you would hear patches in programs or updates. What those updates are doing is that they just go into the code, change some things inside the code of your program, and then give you the new program, and then just eliminate the old program. Okay, that's what patches mostly are. So rather than go through the trouble of doing all that, now you'll have to do that if the distances are hard coded in your program. Okay, but if the distances are not hard coded, if you separate the distances, like you keep the distances in a little file or a database somewhere outside the execution of your program. That's outside the code of your program. Okay, so the distances are not hard coded in your program. When there's a change in those distances, all you need to do is you just provide the user with the new distances. Okay, you do not have the user doesn't have to reinstall the program. Okay, it's just the file containing the distances or the database containing the distances that needs to be updated. Okay, so you just give the user the new file that has the new distances. Okay, we're going to see how all this is going to be done in the next lesson, but for now, rather than say it should just take this float distance, what we need to do is we need to create a method in here. Okay, so we're going to say float distance is equal to get distance, and when we say get distance, we'll need to provide the starting point and the ending point. Okay, I can see this is going to start leading us into coding the actual what we're supposed to do in the next two lessons, because in the next lesson what I intend to do is we're going to see how we can create a database externally. Okay, we're going to create a database externally, not it's not going to be like a complex database like using SQL. No, nothing like that. We're just going to use a very simple file, a text file actually. Okay, we're going to see how you can import a text file into your program. So the distances are going to be written in text file, and then we're going to import that text file into your program, and then you're going to use the distances. Okay, that's for the next lesson. Now for the upper lesson, what we're going to do is we're going to actually code out this get distance method. And before we do that, I'll just show you what the get distances method is going to look like. So I'm going to create the method here. I'm going to make it a private method because it's just going to be within the Form 1 class. Okay, so private, because it's going to return a floating point data, we're going to say float. Okay, that's the data, that's the return data for the method, and then we're going to call it get distance. Okay, and then in there, what is going to need a string. Okay, the first argument is going to be a string. The first argument is going to be the name of the city. Okay, the starting point city. Okay, so we're going to say string start city. So this is going to be the argument, and then a comma, and then the second, there are going to be two arguments. The first argument is the start city, and then the second argument is going to be the end city. So that's the starting point for the journey and the ending point for the journey. Okay, and then I'm just going to put brackets in here. Okay, now what this get distance is going to do is that it's going to return, it's going to take this start city, take this end city, which is going to fetch from the combo boxes. Remember the combo boxes, this one and this one. It's going to fetch the start city from that starting point combo box, and the end city from the ending point combo box, and then it's going to use those two, start city and end city, to look up into the database and fetch the distance between those cities. Okay, that's what we're going to actually code inside this method. Okay, that's in the next lesson. Okay, I'm just preparing the code for the next lesson. Okay, now because when we haven't yet done that, what we're going to do is we're just going to say return 100 here. So we haven't actually written anything, so this is just a test. By the way, why is this get distance in red? There is no argument given that corresponds. Okay, I believe it's because we haven't provided the argument. So we'll just say Kaduna, or actually we can just say start point. We can go ahead and code out here. So we're going to say start point combo box dot text, comma, and end point combo box dot text. Okay. All right. So those are the two details. By the way, notice that if we run this program now, by the time we click on the compute button, this is what's going to be executed. First, it's going to take the allowance per kilometer based on what the user provided. That's one. Then second is going to take the starting point distance as whatever the user selected. Okay, so if the user selected Kaduna, um, this argument, this start city argument, is going to be set as Kaduna. Okay, and this end city argument is going to be set as whatever the user selected. By the way, we can actually test that out, but we're not going to write it out on the form. What we're going to do is we're going to write it out to our output window. So we're going to say console dot write line. We're going to say start. By the way, let's use this. Start city is, and then we're going to add the start city is. We're going to add the start city here. Start city. So it's going to output the value of the start city. We're just using this to test, okay? Just to test to see if this this actually works. That's the start point combo box of text and the end point combo box of text, okay? And then we're also going to say console dot write line and let's not forget the $sign end city is, and then we're going to output the end city. Okay, then also after that, remember in the program we're just returning 100. We're not actually calculating anything. We're just using 100 kilometers for all the distances, but the only difference is that now we have created this get distance method, which in the next lesson I said we're going to use this start city and end city to look up a table. Okay, not the next lesson, in the next two lessons. In the next lesson, it's about importing the database, if you remember. Okay, so let's run this code. The reason I'm using this console.writeLine is I want to test out and see if this start point combo box of text and end point combo box of text is going to actually output the correct cities. Okay, so based on what the user selected. So let's run. Okay, after we run, we're going to come in here and say, okay, payment per kilometer is, let's say, 50. Then notice I'm going to change the start point combo box. I'm going to select Gombe, and then the end point I'm going to select Calabar. And then if I click on calculate allowance, notice it's still using 100 kilometers. Okay, but what you should notice is if you come down to our, so I'm going to click on this that's the Visual Studio. Remember where the output window is. This is where the output window is. Notice that it's saying start city is Gombe and end city is Calabar. Okay, that always gets outputted based on what the user selected. So that is actually working. We can still go back to our program and change. So let's change this to Benin City, and let's change this to Port Harcourt. Now let's click on calculate allowance, and when I do that, notice what's going to happen down here. You can see start city is Benin City, end city is Port Harcourt. Okay, now that means that our setup is actually correct and it's working fine. What we need to do, I've just stopped the application. What we need to do in the next two lessons is to go ahead and calculate these. But in the next lesson, like I said, before we do that, we need to bring in the data or the database for the distances between the cities, okay? So that in this method, we can actually look up the distance. Okay, so see you in the next lesson.